So, Bismillah, salatu wassalam ala Rasulullah. You are welcome to the class. So, as stated earlier, we are going to continue from looking into the work titled Novel Ensemble-Based Techniques for the Preemptive Diagnosis of Rheumatoid Arthritis disease in the eastern province of Saudi Arabia using clinical data. So 3 things are very important there. So as you're going to see, clinical data. So as opposed to the imaging data that are often used. Last time we've briefly looked into it. We look into the ranking of the paper, also look into the human objectives. We look into the data set description, experimental setup, parameter tuning, feature selection, and also further stuff in the summarized form and the future work that are possible for people to look into. So today we, as promised, we're looking into the full paper itself. So that is the full work. So what has been done there? As we know, the title as usual is very important. You need to select the appropriate title for your work, which has been titled a Novel Ensemble-Based Techniques for the Preemptive Diagnosis of Rheumatoid Arthritis. And then the clinical data, like I said, is very important. Now, the first thing, which is very important, as we have discussed earlier, is your abstract. See, this is an open access journal, so anyone can get it easily online. So it's very important that we have abstract, because even for journals that are not open access, the abstract is always available for free. This is where you have to make a very strong case to justify, or a very strong case for the project you are trying to start or you are trying to report to the world. So, and as you can see, rheumatoid arthritis is a chronic inflammatory disease caused by numerous genetic and environmental factors, which could lead to musculoskeletal system pain. So actually this work was motivated by one of the recommendation in one of our earlier works during the presentation at the end of that year. The president actually came around, and then the head of the university came around and recommended that why don't we look into rheumatoid arthritis, because it's usually very challenging for doctors to diagnose and those other complications. So, and we actually found out that, yeah, this is the reality, and so many people, billions of people worldwide are suffering from this problem as of 2021. And the counting still continue. According to the World Health Organization, we're able to establish that quite a number of people are really having challenges with this disease. Another challenges we notice or that have been established in literature is that often, so early diagnosis of RA is very challenging because it is often similar to other illnesses. So, and there is really no definitive test to diagnose diseases. However, people have tried in literature to try to use imaging to diagnose it. Efforts were made, but still were not really up to what people expect, especially when it gets to imaging technology. You need special diagnostic tools, so that might not be available in very simple or remote clinics, as case may be. And this disease is common to everybody. Either you stay in the remote area or not, it doesn't matter. So imaging data pose this kind of challenges often, that you have a system that cannot be easily accessible to people from some special district or less privileged environment. And this is one of the motivation for some of our works. We try to always make use of very simple clinical tests, basic blood analysis. That's enough. Because the belief is before the disease will start manifesting, in any form that image can capture it. It must have been in blood for some time, because the blood is the earlier recipient of any element that enters the body. So that is why, although a lot of people tend to underrate this, but what we have been able to unearth is that a lot of diseases that we often look for videos, imaging, X-ray, might actually be diagnosed very early using clinical tests. And this is what we've been exploring, and the outcome has been confirming that, yeah, a lot of things can be done using clinical tests, which has the advantage that it is always available anywhere. Go to any clinic, either village or remote areas, you can easily do simple blood analysis. Now, so in this case, this study proposed an ensemble techniques that can preemptively diagnose if RA, that is rheumatoid arthritis, is present or not. So doing this, data set have been obtained, and also results indicated that the accuracy has been taken up to as high as 90. It's an excellent level, up to 94.03% accuracy. Of course, there's still room for improvement, but for a starting point, that is really an excellent what to achieve. However, using 30 clinical features at present. So now, so still lots of information, a lot of effort need to be used. So feature selections have been tried out, but more need to be tried to be able to bring down this feature selection, the number of features that is a little bit higher. So now also the next thing in the introduction, which is usually an elaborate literature survey. The introduction is an elaborate abstract, extended abstract, where, because in abstract, you cannot give citation to support what you are saying. For example, now we quoting according to World Health Organization, you can see we didn't put the source there because abstract doesn't allow that. But that we need to do it in the introduction. So introduction, you have that privilege to add as many citations as possible. So I'm basically, as we've mentioned and explained in our previous videos, in the abstract, you need to explain what you want to do, why do you want to do it, and then the why, usually divided into two, the advantage of doing it, and also the second why is from the literature gap. Is there any gap in literature? Something can be important, but then there's no need to do it because someone already did it before. So why do you need to reinvent the wheel? So that's why the literature is very important. We discussed this in our previous videos on how to move forward in the machine learning research. Now, so I've answered the question, what, why, and then how. How do you want to solve the problem? You have to tell how you are going to solve the problem, the method you are going to use, whichever here they are using ensemble techniques. And then the why of how, why are you using the ensemble techniques, you justify it. And finally, you end it with summary of your result. So the same thing you've done in the abstract, you have to do it again in the introduction, but now in more detailed manner. You see, with a lot of citations as much as possible. So because when people read your book, they want to say, okay, are you aware of what has been done earlier? That's why the more the citation in your introduction, the more the respect the reviewers might have for your work. You want to make sure that, okay, what you are writing is not just your own opinion alone. You have been able to check what people have done in the past, and you can build successfully on what they have done. So that is why introduction and abstract is very, very important. So having done that with a lot of justification and references, also a summary of the contribution, depending on the paper you're submitting to. Some journal has a requirement that you need to summarize what contribution you are trying to make in your work. For example, here to implement a novel voting ensemble that achieves a higher classification accuracy for the preemptive diagnosis of RA, in order to assist medical specialists before any symptoms appear, that is preemptively, before the patient actually starts suffering. We want to be able to say that based on what we have in the blood, this person need to get ready as early as possible to get the necessary preventive measure before the disease becomes very pronounced. Reduce the possibility of complication of the late stage identification, so which is also similar to other chronic diseases. The earlier you detect and start treatment, the better. To also investigate the possibility of diagnose RA preemptive diagnosis using clinical laboratory tests. See, like I always say, a lot of people look down on simple clinical tests. Whenever they want to do medical diagnosis, people start looking for images, imaging file, X-rays, CT scan. Yeah, they are very good. However, my little fathers have indicated that before those imaging can really detect things, it's always towards the late stage or middle stage. At that point, organs will have been affected before you can see it physically, you see those imaging. However, blood or simple clinical tests can really show us the first port of contact when any foreign stuff gets to the body is the blood. So why don't we quickly concentrate on trying to, unfortunately, a lot of people ignore because they see it as very simple. It's very simple. Clinical test is nothing, but I can say that it's something. And it's, from my own little experience, is by far the most important place to first of all call when you are trying to investigate if a disease is present or not. And with machine learning, I want to believe a lot of work needs to be done in this area to take advantage of this technology to assist people to get the status of their health at a very, very early stage before any devastation takes place in their system. So that is one of the achievements that we're able to investigate the possibility of diagnosing RA, rheumatoid arthritis, preemptively using clinical laboratory tests. And then the proposed model generally achieved the highest outcome compared to benchmark studies. So compared to earlier works, it was better than whatever could have been done. Now, having said that, the next thing we move further is the review of related literature. So we did a very detailed literature survey, as the case may be. After that, we're gonna have the what we call the methods, materials and methods. It's very, very important. So what we have done, abstract, introduction, literature review, where you're going to establish what has been done. In the literature review, it was established, no one ever did this particular kind of investigating predictive capability of an ensemble system on clinical data for diagnosing rheumatoid arthritis. Yeah, earlier works focused on using imaging to try to solve the problem. Like I said, with challenges of lack of imaging equipment and even the accuracy reported or performance measure was still very, very low compared to what has been achieved in this work. Now, so from literature review, it has been established that there is serious need for this kind of work, especially as people trying to underrate the power of simple clinical tests in the medical diagnostic process, with a lot of emphasis being placed on imaging technologies, which of course they're very good. However, before imaging system can detect a disease, often it means that disease already in a kind of pronounced stage. So with clinical tests, the work has been able to establish that, yeah, you can actually do a lot of investigation before things get really clear from an imaging point of view. So in the material and method, which is the next thing that is very, very important, you have to document what you have done, how you have carried it out. So the study built RA diagnostic model using Python programming language. So and then using the constant random state value of 42 for all operations. That is, when you randomize data, you specify the random number so that it will be repeated. Anytime you break the data set, you always get the same system. So the data set has been divided into two, which is 70 for training and then 30 for testing. And then you can see here what we call the rheumatoid arthritis prediction framework. This is the framework. I think we discussed this earlier in the first video on this paper. So where you have data source, There are two data sets that are merged together. So combining processing took place. So percentage place 70-30, very, very important. You read any machine learning paper where you cannot see how they have divided their data, then you better just avoid reviewing that paper, because without specifying how you have divided the data, how will someone repeat the experiment? Because that is very, very important step. And then other stuff, we have the experiment with smooth, where they try to do balancing the data, and another one without smooth. All the results were recorded. So using the grid search was used for the parameter optimization, or what we call the hyperparameter value optimization, using 10-fold cross validation. And finally, you have the experiment on voting. So different ensemble systems were tried out. The first one you have without smooth, then you have with smooth. That is the one without balancing and the one with the balanced data. So feature selection were also tried, like sequential forward feature selection, sequential backward feature selection. So we described this also earlier in our earlier videos, or the main. And also finally, the evaluation of the model to see the performance accuracy, the precision, the record, and then the ROC, as the case may be. Now, also under the materials and method, data set description is very, very important. See, data set description has to be presented, where you are going to list out the feature and then the description of those features, so people can know. So this, like I said, most of them are basic analysis from clinics, that is from clinical investigation, especially the blood tests that were done. So after describing that, also, you also have the statistical analysis for the numerical features. Those features that are numbers, we do statistical analysis for them, like the age, MCH, and also further. Each of them has been defined in the table we showed earlier. So you want to tell us the minimum, the mean, the standard deviation, minimum, 20%, 50%, maximum. If there are missing value, how many missing values, as the case may be. So this analysis are carried out, because we are looking at the mean and the standard deviation. You could have all the minimum and the maximum. You can be able to see if the data is the kind of distribution the data is falling out, and so many other statistical analysis you might add to it. Now, here you can see it is mentioned that it's the statistical analysis for numerical features, for features that has numbers. For features that are categorical, for example, gender, male or female, you cannot find the mean and median. Here you can do the analysis by telling us how many males do you have and how many females do you have in the data. This is the kind of analysis, statistical analysis you can do for non-numerical features. Tell us how many do we have from each of the discrete values that are represented in the data set. So having done that, also you see the correlation coefficient, or what we call the correlation heat map. Try to see how the set of features correlates with the target. So this can be done from any perspective. Weka also can do it for us. You can even do it in Excel file, making it very simple, as the case may be. Now, so having done that, those are the method. The next thing to move on to is they also carried out the performance, still on the material method. They carried out what we call hyperparameter value optimization. See, in the hyperparameter value optimization, here you're trying to see which of the hyperparameter value will give you the best. You can see several investigations were carried out here in this sense. See, because you have to try to check. So what is the value of C? What is the value of C? That's going to give us the best possible value. So you investigate it. I believe we have described how to do this. Even in Weka, we have demonstrated that When I say we have simple method, you can also have grid search, which is what has been used in this particular experiment. So you try to check for the C, what is the value of the C that is going to give us better result, as the case may be. Now, so also a couple of pre-processing were done maybe on the data set. Sometimes you see that the data, there are missing value, you treat the missing value appropriately, depending on the kind of problem you can figure out in the data. And then also see on those parameters, you see a lot of parameter value. The most important thing, you have to summarize it as the case may be, to be able to see, okay, what are the hyperparameter value that will give you the best possible result. All these were well documented in the system, as the case may be. So each of the algorithm that has been selected, you have to check out the hyperparameter value, which we call it, this is ADA-boost hyperparameter tuning. So we have to check it out. Plotting it is not compulsory, but usually it makes it easy for you to track what you have done. You can see as they change the parameter, it keeps changing. This is parameter estimator. It keeps changing, going up until it stabilizes, and then the performance goes down. You can easily see that, okay, this is going to be the optimal value that we're going to use for this hyperparameter. See? So, and then it's always good to have the optimal hyperparameters for each classifier, a summary table that will summarize all what you have displayed in these kind of diagrams. I say it's not compulsory, but also it's always good. Actually, reviewers sometimes love that, because that is a way to let them know that you have actually carried out the experiment. See, that it's not that you are just making up numbers. You can see evidence of experiments carried out appropriately. Now, so you have to summarize the hyperparameters in a table for each of the experiments and for each of the classifier. This SVM for experiment 1. So this SVM for experiment 2, because one was having imbalanced data, the other one was having balanced data, as the case may be. Now, another thing also is we often present here the description of the proposed techniques. So how the proposed techniques go, it's always good to present it. So as clear as you can, especially making it clear. This is mathematical, little medium mathematical representation of support vector machine has been presented, how it works, logistic regression, and host of and the other method that have been utilized. You make it clear the optimization strategy you use, which is grid search that we have discussed earlier. And then you also try to see that, okay, once you have optimized the algorithm, that is, you have checked the hyperparameter values of them, then you try to see that, okay, what next can I do to hopefully get a better result from the work that we are currently working on. So one of the areas that the authors have looked into is to make it very clear how different experiment has been set out and to explore different possibilities. Because like I say in machine learning, you cannot really tell which one is going to give you the best result. So that's why there's always the room for try and error. Check many possibilities and then try to come up with the one that is good to get the best result, and then you can compare. So that is why you need to have a very well spelled out the voting ensemble that has been identified, all spelled out, you can see here. So you have the SVM, the linear regression, and the other boost, the combination. Here you have 3 from SVM, 2 from this, and you can see SVM with cos 5, gamma, kernel, this one with cos 6, C is equal to C, gamma is 0.1. So you can see different hyperparameter value, because we found out that each of these got better predictive value than others, they selected the best among them. You see, so that hoping that when you combine them together, they can get better result than what individual will get. This is the idea of ensemble. So this one is a little bit better, but it's making some mistake. This one is having some mistake. Maybe mistake of this one, we cancel this one, or the mistake from these two, we can cancel this. This is the essence of ensemble. For those who are new, I recommend that we can try to check out some of our ensemble videos where we describe ensemble techniques. Because sometimes when individual models cannot take you to the promised land, that is what we are expecting in terms of accuracy, because sometimes individual model can get stuck, that they cannot improve further. Even though you have done hyperparameter optimization, you have done feature selection, you cannot just get them to improve the result. In that case, you have to start thinking, maybe it is time for me to combine together ensemble, perhaps we can get better results. So this was deeply investigated here. Different ensembles were tried. At the end of the day, you can see all 1, 2, 3, 4, 5, 6, 7. 7 different models were fused together to make them to vote. So whenever you have a sample, we say, what is your opinion about this sample? What is your opinion about this sample? So this one is saying the answer is positive. This one is a positive. This one is saying no, negative, negative, negative. This one is positive, positive. So we have 5 against 2 or 4 against 3. That's why it's always good to have odd numbers of models, so that when they are going to vote, you don't have a tie, because we want to avoid having tie, whereby 3 people said yes, another 3 people said no. How are you going to decide? So, however, the more the number of ensemble you can build, the better. You see, 7, it's okay. At least they're able to get 93 point something or 94. However, we have seen cases whereby you might have to build up to 161 ensemble model. Each of the model will be 161 to be combined together to form an ensemble. So you keep building them. The unique thing is make sure you cannot build them to have the same parameter. You see, having this parameter means the hypothesis function is going to change. When cos becomes 6, it's going to be a totally changed parameter hypothesis function. You keep generating different hypothesis function. And there's also a rule in ensemble that it is good for you to try and make use of different machine learning algorithms when you want to build the ensemble. You can see here we have 3 from SVM. There are advices that don't make all of them to be SVM. You have, like, I want to build SVM like a 21 or 115 SVM. I can build it and then make them vote. However, it is discouraged. It is encouraged that you try to have mixture of different algorithms, because they are going to look at the problem from different angles, because their own theoretical foundations are different. So we want to have diverse opinions, or you want to have opinions of diverse models, from different backgrounds. So that's why you can see here, you might want to build your own with as many as maybe 7 SVM, 15 LR, and then other, depending on the accuracy they reported while you are training them. Because you cannot bring something that is getting 20% performance to come and compete with someone with 97. It might bring them down. So that is why you have to check which ones are going to giving us better result. Then we can try to combine those things. Hopefully, they're going to give us a cumulative better decision finally. On the imbalanced data set also, they also tried it out here. You can see here in the imbalanced data set, the balanced data set, they tried 3 for SVM, 3 for this, and 1 for Adabos. Because those are the ones that were performing, the best 7. There were several models were trained. Then selecting the best 7 and make those best 7 to come and vote to take the decision. And yet later you see the test data, you're going to get the final result. So this is how the experiments have been clearly set out, as the case may be. So the next thing that they look into is, okay, how can we then improve this result from the side of feature selection? So which kind of feature selection did they use in this work? How was the feature selection carried out? Does the feature selection really improve the results? Could it have used a better feature selection? So these and other questions, by the grace of God, we are going to answer them in the next episode of the presentation of this ongoing studies or ongoing study that where we do exposition of earlier work that has been published. So these are going to be some of the questions to be answered, God willing, next week. So we want to give room for question or clarification on the little we have discussed today. Thank you very much all for listening as usual. And wish you all the best. Thank you. And then we can raise up our hands for question or comment or clarification. Thank you very much.